this. Let's see how we go. That's already slowing down. So we're going to have a look at derivatives of e to the x and ln x, like so. Okay, so again, this is just presenting you with the practical things rather than the understanding of why it is. So here are the basic ones. Given y equals e to the x, then dy by dx is equal to e to the x. Okay, so e to the x is a special power where its derivative is equal to itself. Okay, guess what the second derivative is? E to the x, and the third derivative, and the fourth, and the fifth, and the sixth. In other words, it will just keep on going on forever as e to the x. Okay, so that's one. Now we deal with e to the x and ln x at the same time because they are inverses of each other. Given y equals ln x, so remember that means log base e of x, dy by dx is equal to 1 on x. Why? Because it is. Okay, so those videos that I showed you before will explain the concepts behind that. So all I want to do now is go through some examples. Yep.
Does that mean that the second derivative is the thing that we did the other day on the homework?
So the second derivative would be negative 1 on x squared.
Okay. Oh, yeah, 1 on x squared.
Although the thing you did for homework, Lily, was first principles approach. You used the power law.
Okay.
Yes. Okay, so examples. Now this is where I left my notes back in the office, so I'm just making it as I go along. Y equals 2e to the x. Therefore, y by dx is equal to 2e to the x.
Oh, because we're not bringing anything down.
Yeah, it's as simple as that. So when you multiply a function, it's using this idea that, I won't write it down, but if you multiply the function by a constant number, you just work out the derivative of the function and multiply by that number. 2y equals 3 ln of x. Therefore, the y by the x is equal to 3 on x. Okay? 3 times 1 on x, which is 3 on x. Yeah? Okay, example 3. Told you I'll be quick. Y equals a half ln x. Therefore, the y by dx is equal to 1 on 2x. It would be a half times 1 on x, which is 1 times 1 is 1 on top, 2 times x is 2x on the bottom. Is that okay? It's alright now. I'm going to introduce you to a new rule, very informally. We've actually got a unit which covers it properly. But they're so simple that if I don't introduce this rule, you'll end up with very basic stuff to practice. What happens if I've got y equals e to the 2x? Believe it or not, it looks really simple, but there's a trick to it. When you start having a more complex thing as the power there, you actually have to treat it differently. It's not just e to the 2x. In other words, you need to always remember that if it doesn't fit a pattern perfectly in mathematics, there's usually something you have to do to fix it. In this instance, we're going to use a very simple approach to what we call the chain rule. The chain rule says, if you've got a function of a function, find the derivative of the inside function first, and then find the derivative of the whole thing. So, the inside function is 2x. What's the derivative of 2x? Yes. So I'm going to spell this out. 2 times, and now I find the derivative of the outside function, which is e to the something. And the derivative of e to the something is e to the something.
So it doesn't matter what the something is, if it's got an e in the base, it's always just going to be itself.
As long as you find the derivative of the something as well.
And you keep the 2 up there.
So if it,
in the power.
if it was like,
Sorry, I didn't write it very well. That was an accident of mine. Therefore, dy by dx equals 2 times e to the 2x. Okay? So I find the derivative of the power, and then I find the derivative of the whole thing. Tricky, huh? Similar with ln(x). Maybe you can see if you can get ahead of me. So y equals ln of 2x. What would dy by dx equal? Give you a moment to work it out yourself. Did you get 2 ln 2x? Oops, sorry, start that again. 2 over 2x?
Wait,
We've got 2
Oh.
over x.
wait,
So you find the derivative of the inside, which is 2, and then you find the derivative of the whole thing, which is 1 on that.
Oh, because whatever it's in ln, it's just going to be 1 on whatever's in
1 on 2x in this case.
there. Yeah, 1 on whatever the x times. Whatever the time.
Whoa.
Okay.
So the derivative of ln always ends up being 1 on x, doesn't it? Because if I said ln of 3x, that would be 3 on 3x, which would be just 1 on x. If I said ln of half of x, that would be a half over half x, which would be 1 on x. So whatever that constant number is in front of x, it always end up cancelling out. So you always get 1 on x. Yeah.
Would it be like 2x squared?
Would it ever be?
Would it?
Yeah, could be. I was actually going to do that, Aaron. I'll do it properly in the chain rule later, but this is just another, I forget the number, 2, 3,
Can you go back to the 8th one?
yeah. This is just one.
Oh, but it's
So-
slide.
If I had y equals e to the 2x, then the y by dx would be, sorry, I beg your pardon, x squared is what I meant to write. I was thinking ahead. The derivative of x squared is 2x, and then the derivative of e to the x squared is e to the x squared. So you end up with 2x e to the x squared. And to complete, if we have y is equal to ln x squared, then the derivative is 2x multiplied by 1 on x squared. One on x.
So in 6, when you make it 2x, you don't have to make it 2x to the minus 1.
Well, the derivative of x squared quite simply is 2x, isn't it?
Oh, yes.
So it's just a power rule.
Yeah.
You asked me to go into slide 8, Lily?
Yeah.
I think you asked me to go into
Yeah.
slide 8. Okay. The one more example I wanted to go through is the one that I wasn't really confident with. I had a particular function I wanted to go through. So find, this is what example is this? 8. X equals 3. And x equals 3. So let's just quickly do this so you can sort of see how to do this. So we're finding the normal, which is the straight line that is at right angles at that point to the curve. So to remind what we do there, we have to work out what the slope is at that point. I then have to find out the perpendicular slope. I then have to substitute in a point to finish off. So this is what we're going to do. So first of all, the y by dx is equal to 2e to the 2x. And then at x equals 3, the y by dx is equal to 2 multiplied by e to the power of 6. Okay, that's the gradient. It's a number. E is about 2.7, so it's 2.7 to the power of 6 and then double it. I don't know what that is. I don't care. I'm just going to leave it in the exact values. E is not a variable. It's a constant number. Okay, so I have found my gradient. Also at x equals 3, y is equal to e to the power of 2 times 3, which is equal to e to the power of 6. So my coordinate is 3, comma, e to the power of 6. Good so far? Well, I'm alright then. We know for the normal, we have gradient is equal to, you flip it and make it negative. So it's negative 1 on 2e to the 6th. Is that okay? So for a normal, it's n1 times n2 equals negative 1. So you take the first gradient, multiply it, you flip it, and you make it negative.
So what do we find there? The gradient of a tangent.
It's exactly the same. So for a tangent, the gradient is equal.
Yeah.
So it would be 2e to the 6.
Yes, and then you.
But Richard, that M1 and M2 formula, isn't that just for perpendicular lines?
So normal means a normal line is perpendicular at that point. Yeah, that's the definition of a normal. It is perpendicular at that point. This is good revision, isn't it, for that sort of stuff? So absolutely ask the questions. Good so far? Okay, we're nearly there then. Therefore, equation of normal, just got to put all those pieces together, is y minus, what's the coordinate I had, e to the 6, is equal to negative 1 on 2e to the 6th outside of x minus 3.
That's it.
That's it?
Do you just leave it like that?
Yeah, you can. Now, if you want to, you could simplify that. You could expand the right-hand side.
No.
You could add e to the 6th to the left-hand side, and you could eventually get it into y equals mx plus c format. It would take some doing to do that, and it would look pretty ugly, but there's no reason why you can't. It's just straightforward expansion. Just don't get tricked into thinking that e to the 6 is anything magical. It's not. It's ultimately just a number. So you've got y minus a number equals some gradient times x minus 3. It's just that it looks tricky. And that's basically it. That's how you can use derivatives to work out normals and tangents and stuff like that. Okay, I'm going to stop the video here, but if you go over to your schedule of work, you'll see there's exercise 9M on page 424 with a bunch of questions there. So try and get through those questions by Thursday so that you are ready for the final push before our exam.